Hello and welcome to another maths video. We're going to just introduce for you today the cosine rule. Cosine rule is given to you on the formula sheet, which is nice. It is fairly different to the sine rule in terms of how it looks, how it kind of works though. So without further ado, this is what the rule says. It says that c squared equals a squared plus b squared minus 2ab cos C. So quite extensive in terms of how it looks there. You can rearrange it as well. So if you do rearrange it, the other version of it says that cos C equals a squared plus b squared minus c squared on 2ab. Okay, so that's the same thing, just rearranged. In terms of using it, what's useful, what's nice, looking at the top version now, the top version we have C by itself, so this version here is better for sides. This bottom version here, the angle here is by itself because of the angle, so this is better for angles. Okay. What you will note about the cosine rule is that it's linking side, 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 angle. So we're dealing with side, side, side. We're going to get A and B again just for bonus, and an angle. Okay, so three sides and an angle, cosine rule. One angle is the cosine rule. The sine rule, of course, dealt with two sides, two angles, so this is a little bit different. In terms of setting up a question for it, if I grab just what might be a question, if I take this thing here, and let's say I'm trying to find, let's call it A, B, and C. Let's say I'm trying to find C here, some unknown theta, and I've got side lengths of 3, 4, and 6. I will say, well, generally a good thing to do is recite the rule first. So I'm trying to find an angle here. I want the angle version of the rule, which is cos C equals a squared plus b squared minus c squared on 2ab. And it's good to memorize them, it's good to know them, but of course if you need to go for the formula sheet, you might have to do a little bit of rearranging to get the different forms, but it's just a little bit of algebraic manipulation to get the other different forms. In terms of our question here, what we would have then would be that cos theta would be, well, sidewise, this is A, this is B, and this is C. So cos theta would be A squared, which is 4 squared, plus B squared is 3, minus C squared, so minus 6 squared on 2AB. 2 times 4 times 3. And it is quite robust, it will always work. So sine rule, you saw the sine rule was a little bit falling apart in places when I did the examples, when I did the rule. Cosine rule, a bit more robust. It basically can take anything you can throw at it. So going through this, cos theta equals 16 plus 9 minus 36 on 8 times 3 is 24. That's going to make 25. It's going to be minus 11 on 24. So cos theta is minus 11 on 24. Shift cos both sides, we get theta is shift cos minus 11 on 24, which is 117 degrees. So theta here, 117 degrees and 17 minutes. Okay. It's okay, when you will notice here, this is a little bit funny with the cos theta coming out negative. That's because, again, looking at your choose angles, A, S, T, C, everything was positive here, only sine was positive here, so we can expect here cos is negative. So because cos is negative here, I do get an angle in that quadrant, in that second quadrant. Cos is negative, comes out being 117 degrees. Obviously, it can't be over here. If it was over here, you're talking an angle sum. Well, that's 180 degrees in there. So anything bigger than that, you're not getting a triangle anymore. Triangle, angles add to 180 degrees every single time. So label it up, substitute it in. Okay, the two rules, they are a little bit tricky, but get to know them, get familiar, get substituting in. In terms of identifying when to use them, we're using 3 sides, 1 angle. 3 sides, 1 angle, cosine rule every single time. Okay, if you're ever dealing with 3 sides, no right angle triangle, 3 sides, no right angle triangle, always going to be the cosine rule for you. That's just a little introduction question. Next we're going to push out the proof of this, and the proof is not as nice, it's certainly algebraically more challenging. So as we go through it, feel free to pause, stop, have a rest break, get a drink, get some oranges, who knows, whatever you like to do to get a little bit of refresher for maths. So the proof. We're going to start again, similar to what we did with the sine rule. I'm going to start with the triangle, and I'm going to draw myself an altitude in there. I'm going to call that C, that'll be A, that will be B today, H. So I'm going to say for my marker, I'm construct an altitude, H through A. Okay, so my altitude, H going through point A in there. In terms of labeling sides as well, so just so we know, we've got B here, this is C, this whole thing is A. What I'm going to do, I'm going to call this part here, this distance in here, up to the altitude X, which means that this distance here will be A minus X. Okay, so if I add both of them together, X and A minus X, I do get A. So that length there plus that length there is the total length across the bottom here. Then what I do, I revert back to my good friend Pythagoras. So Pythagoras theorem on my 2 triangles. I'll do this triangle here first. I'm going to change it to pink actually, keep it all pink. So this triangle here, Pythagoras, and I'll do the same again on my green triangle in a second. So on my reddish triangle, my Pythagoras theorem says that x squared plus h squared equals b squared. And you can say in brackets if you want Pythagoras. In my green triangle, working that as well, I'm going to get a minus x squared. That's that bottom side there, that side there, plus h squared equals c squared. So once I've got that, what you'll see, I mean, I know my cosine rule says that c squared equals a squared plus b squared minus 2ab, cos c. The thing with what I've got down here, it's really messy, and then I've got h here, I've got an x in here as well, so h and x, whereas they both don't appear in the actual version of the rule. So I need to eliminate both the x and the h. Once I've got my setup all done here, eliminate the h and the x, I'm going to start by eliminating the h's. So I'm going to rearrange both of these, similar to the sine rule, to get h squared by itself. So here I'm going to say that h squared equals b squared minus x squared. And over here, h squared equals c squared minus a minus x all squared. So now these two are actually equal to each other. So I can say that h squared equals b squared minus x squared, which equals c squared minus a minus x squared. So again, that's equal to h squared, that's equal to h squared. So because they're both equal to h squared, these two here are equal to each other. Okay, so pull it out for my next line of working. So if I have b squared minus x squared equals c squared minus a minus x squared. I'm going to expand this now. So this is c squared minus, that would be a squared minus 2ax plus x squared. If you're not good at expanding it, terms like this, please make sure you get good. This is very essential skills at this stage. So b squared minus x squared is c squared minus all this, so b squared minus x squared equals c squared minus a squared plus 2ax minus x squared. What I've got now, I've got minus x squareds on both sides. So I'm trying to cancel, I'll give that the flick. Okay. So I get now that b squared equals c squared minus a squared plus 2ax. I'm going to rearrange now to get the c squared by itself. So this here I'm going to keep, this stuff over here I'm going to kick to the other side. Or I'm going to say that c squared equals b squared plus a squared minus 2ax. What you're going to notice at this point is I've still got an x in here. So this x here, it's bad news, it's got to go somehow. Okay. So, and I need to get, looking back at my rule as well, that x there, being the cosine rule, I need to get a cos c in there somehow. There's no c in what I've got. If you're writing it down, you'll see pretty clearly, or you can go back a second or two in the video. You'll see there's no cos c in what I've got so far. So what I'm going to do, I'm going to approach this triangle here, the red, because c is in there. And if I take cos c in that right angled triangle, cos c is adjacent over hypotenuse. So my adjacent here is x, my hypotenuse is b. This is equal to x on b. Okay. Multiplying both sides by b, to be or not to be. Multiplying both sides by b, that'll cancel, and I'll get b cos c equals x. So b cos c equals x, that is going to be very important. I'm going to substitute that back in down the bottom. So x is b cos c. Got it. So x is b cos c, write that down again so I don't forget. X is b cos c, and I'll get c squared equals a squared plus b squared, just alphabetical order those, minus 2a b cos c. So I get c squared equals a squared plus b squared minus 2, if you expand that, a b cos c. And there's my cosine rule. That's what the rule says. Okay. Oh. I can get the other version by a little bit of rearranging, but that is the first case of the rule in there. Okay, so my proof is now completed. You can say as required. There's a bunch of things you can do in terms of formally ending your proof, or you can put the big solid block here that says I'm done. That's the proof, and that is, I suppose, a very early example. Again, proof-wise, you can be asked to reproduce it. It's pretty nasty. I wouldn't expect you to do it. I think in terms of understanding the rule, where it comes from, it's necessary. Big things with the rule, kind of going back over just to get some key points out of the video for you. This is the cosine rule. These are your two versions. One for sides, one for angles. You can rearrange. They are given to you on the formula sheet. Okay. What's important identifying, and I'll highlight it again, super important, is that your cosine rule is going to be 3 sides, 1 angle. 3 sides, 1 angle, cosine rule, every single time if it's a non-right angled triangle. Otherwise, guys, I'll put an example video up, just some examples of this in a few minutes. Thanks for watching, and best of luck having a go at this for yourselves. Bye.